What if you could know, I mean, really know, that one of your key machines was going to fail long before it actually breaks down? Today we're going to dive into a totally new way to see inside your equipment, a way to get a heads up that could literally save you from a catastrophic failure.
It all kicks off with this really dangerous idea that we all believe, that a dashboard full of green lights means your system is healthy, right? We're all trained to wait for the alarm, for the temperature to get too high or the pressure to drop. But here's the kicker. What if, by the time that alarm finally goes off, the real damage is already done?
So, here's the big difference. Your standard monitoring system is totally reactive. All it does is ask, is this number too high yet? But FSME Logic asks a much smarter question. It asks, is the signal still behaving like it's supposed to? Is it still breathing? You see, it's reading the deep mathematical pattern underneath, and it flags the moment the physics of the system changes. That's how you go from being reactive to being truly predictive.
So how on earth does it do that? Well, it's all about reading something that your current systems are actually designed to filter out and ignore, the signal's own memory. And this isn't just some clever piece of code. It's grounded in the real-world physics of how things actually wear out and break.
The secret sauce is a concept called entropic elasticity. Now that sounds complicated, but think of it simply as the aliveness or the breath in a healthy signal. You see, every healthy system has these tiny, natural, kind of random fluctuations. That's a good thing. It proves the system is elastic and responding to stress the way it should. It should never be a perfect, dead flat line.
And this, right here, perfectly shows the two states of any machine. A healthy signal is elastic, it's breathing, it's alive. But as a part starts to wear out and fail, that natural randomness just disappears. The signal gets stiff, rigid, and way too predictable. It basically crystallizes. We call this an entropy collapse, and it is the physical warning shot that comes right before mechanical failure. And look, this isn't just some wild theory we cooked up. The core physics behind this, the idea that systems remember what just happened to them, has been independently confirmed by major players like Google Quantum AI and Brookhaven National Lab. Physical systems have a memory. FSME is simply built to read it.
Okay, so that's the science. But let's see how this all plays out in the real world. What is the actual, tangible, dollars and cents cost of trusting that everything is fine green dashboard?
For anyone in industrial operations, the cost of being late is just staggering. A single hydraulic pump failure, if you only catch it after it breaks, can easily run you up to $150,000. That's when you factor in all the downtime, the emergency repairs, and all the collateral damage.
This data from a real hydraulic test rig just proves the point perfectly. Now, I want you to look at the bottom row here, motor power. That's the channel everybody watches, right? It didn't flag any problem until cycle 211. To an operator, the screen looked green, but now look at the top row. The vibration channel caught the problem way back at cycle 51. The physics of failure was basically screaming for help through 5 other channels while the most obvious one looked totally fine.
I mean, that's really the whole story right there. The one thing you were told to keep an eye on was the very last to know something was wrong. That is the green dashboard fallacy in action, and it is costing you money.
So, what was the time gap? The difference between that first flicker on the vibration channel and the final alarm from the motor power was 160 cycles. In this specific test, that translated to 160 minutes of warning. That's 2 hours and 40 minutes of actionable, money-saving time you didn't have before.
And what does that warning time actually buy you? Well, it's the difference between an $8,000 planned repair and a $150,000 catastrophic failure. That 160-minute window isn't just data. It's a massive financial opportunity.
And you know, this principle isn't just for hydraulics. This pattern holds true everywhere. In commercial refrigeration, FSME saw a 54% jump in entropy while the main thermometer was steady as a rock. On industrial bearings, it caught all 9 major fault types hours before they would have torn themselves apart. The physics is universal. But to really get the credibility of this engine, we have to look at the highest possible standard there is. Let's put it this way. If this math works in deep space, it's absolutely going to work on your factory floor.
The exact same mathematical engine, with the very same parameters, has been validated on public data from NASA and the European Space Agency. We're not talking about just any data here. We're talking about the Curiosity rover on Mars, entire fleets of commercial jet engines, and live satellites orbiting the Earth.
This is the number that just stops engineers in their tracks. On the Mars Curiosity rover, FSM spotted the signature of an actuator failing 6.3 hours before NASA's own systems even labeled the failure. Let that sink in. 6 hours of warning on another planet.
And it scales beautifully. Just look at this audit of a fleet of 509 commercial jet engines. FSME correctly identified 78% of all the developing faults. That's that huge slice of the chart right there. On average, it gave a lead time of 126 flights. Do you know what that means? It's the difference between a planned overnight repair and an emergency that grounds a plane and costs a fortune.
Okay, so the proof is there. It's undeniable. But how do you actually put this to work for you? Well, the entry point is designed to be simple, fast, and incredibly low risk. It's a forensic audit using the data you already have. And honestly, this might be the best part, and it's a huge reason people get started with this. There is no new hardware to install, no cloud subscription fees, no complex, expensive, and time-consuming system integration. We designed this to be the easiest yes your operations team will ever say.
The whole process is just 3 simple steps. 1. You export raw data from whatever system you're already using. 2. We run the audit on our local, offline hardware. Your data is completely secure and it never touches the cloud. 3. You get a full forensic report telling you exactly what we found. It really is that straightforward.
The investment for a full forensic pilot audit is $8,000. Now, when you compare that to the $150,000 cost of just one unexpected failure, the return on that investment isn't just clear, it's immediate. This audit can pay for itself almost 20 times over by preventing just a single unplanned shutdown.
So we'll just end with this one question. Right now, at this very moment, inside your facility, your equipment is generating signals. And those signals have a memory. They hold the true story of what's really happening on a physical level. The only question left is, are you listening to it?